Hello everyone. In this lecture, we are going to discuss the topic functions. Let us start with the definition of functions. Let x and y be two non-empty sets. X and y be two non-empty sets. Now, a function f is a rule which associates to each element x in this x a unique element f of x in the set y. Okay, that is, let these two x and y be two non-empty sets. Now, a function f is a rule which associates to each point x in capital X a unique point f of x in capital Y. Okay, symbolically we can write this as f from capital X to Y, where x and y are non-empty sets. Okay, now let f be a function from this capital X to the set capital Y. Then for a point small x in capital X, f of x, that is, this f of x is called the image of small x under the function f. F of x is called the image of small x under the function f, or it is called the value of small x under the function f. Okay, so in that case, this set x is called the domain of the function f, and the set y is called the codomain of the function f. Okay, now what is the range of the function f? Actually, the range of the function f is a subset of the codomain y formed by the set of all values of f. Okay, that means the range of f is equal to set of all f of x belongs to y for x belongs to x. Okay, that means range of a function f uh, is the collection of all values of uh, x in x. Okay, collection of all values of x in x under f. Okay, that is the range of f. If these sets capital X and Y are subsets of set of all real numbers R, then uh, the function f is said to be real function, or real valued function, real valued function if x and y are subsets of R, set of all real numbers. Okay, now we can discuss some standard functions. Some standard functions. First one, a constant function. Constant function, that is f of x equal to some constant c for all x belongs to R. Okay, that is the constant function. So what will be the graph of this function if this is y axis and this is x axis, or this is y equal to f of x and this is the coordinate axis, x axis. Okay, in the graph of f of x equal to c is actually, it is for any value of x, we have the functional value is constant c, so the graph will be like this. Okay, so this is the point y equal to c. Okay, so for any value of x, the functional value of the value will be c, right? So this will be the graph. Now what will be the domain of this function, domain of this constant function? So here we can assign any value, any real number for x in this function x. Okay, the f of x equal to c. In f of x equal to c, we can assign any value, any real number x for this function. Okay, so therefore the domain is nothing but equal set of all real numbers r. So for any real number x, we can define or we can the function is defined. So domain is r. Now what about the range of this function? Range is also range is equal to this singleton set C, because for any value x in R, we have the functional value is nothing but, or the image is C only. So this is the only image C. Okay, so range is nothing but the singleton C. Okay, so next, the second function is identity function. Identity function. We know the identity function is f of x equal to x for all x belongs to R. So can you imagine the graph of this identity function? Graph of the identity function will be like this. This passing through the origin. Okay, this is y equal to x. So if this is x-axis and this is y-axis, then graph of this identity function is equal to this. That means identity function maps any point in the real number in the set of all real numbers to the same point. Okay, the function maps a point to itself. That is the identity function. So what about the range and domain of this identity function? Here the domain is nothing but R itself, because we can take any value, any real number for x here, and also the same will be the image. So range is actually the real number, a set of all real numbers. Okay. Now another function is reciprocal function. So it is nothing but f of x is equal to 1 by x for x belongs to R minus 0, because for x equals 0 it is not defined. For x equals 0 it will be 1 by 0, which is not defined. So we cannot take the value 0 for x. Okay, so therefore the domain will be set of all real numbers minus the singleton 0. Okay, now what about the range? The range is also set of all real number r minus 0, because uh, this function will not assume the value 0, because 1 by x should not be equal to 0 for any x. Okay, so it will not assume the value 0, so the range is also r minus 0. Okay, so what about the graph of this function? Graph of this function will be like this. Okay, so it will not take the value 0. This is x-axis and this is y-axis. So it will not assume the value y equal to 0, and it is not defined at the point x equal to 0, right? Next, exponential function. Exponential function. So an example of an exponential function is e power x for x belongs to R. F of x equal to e power x for x belongs to R. So what will be the graph of, or the graph of this exponential function? That is nothing but like this. Okay, so this point will be, this is at when x equals 0, we have e power 0 is 1, so this point will be 1. Okay, so what will be the domain and range of this exponential function? So domain is nothing but this function is defined for all x belongs to R. Okay, for all x belongs to R, it is defined. Okay, so domain is the set of all real numbers. And what about the range? Range is uh, that means it will assume the values which is greater than 0. So it will not take the value less than 0. Okay, that means the graph uh, uh, is not included in this region. Okay, so range will be set of all y belongs to R such that y is greater than 0. Okay, because e power x is not equal to 0 for any x belongs to R. So 0 will not be a point in the range. Also, e power x is not equal to is not less than 0. It's not less than 0 for any x belongs to R. Therefore, any real the range contains only the positive real numbers. Okay, so it will take only values from 0 to from will take only the positive values. Okay, so the range will be uh, non-negative or no, it is positive numbers only. Okay, next is modulus function. Modulus function. Okay, modulus function is actually f of x equal to is denoted by mod x, which is and is defined by x if x greater than 0 or greater than or equal to 0, and it's minus x if x is less than 0. Okay, so what will be the graph of this modulus function? If you draw that, we'll get from this suppose for a value for x equals 0, for x equals 0, what will be modulus of x, which is coming under this region. So modulus of x is equal to 0 itself. If x is greater than 0, then the modulus of x is itself. That means if x equal to 2, then modulus of x is equal to 2 itself. Okay, and if x is less than 0, that means, for example, if you are taking x equal to minus 2, then what will be modulus of x? Modulus of x is, if x is less than 0, then we have the modulus of x is negative of that x, that is negative of minus 2, that is 2. Okay, so we can conclude that for any real number x, function will the functional value will not be negative. Okay, it will be greater than or equal to 0. Okay, from this. Okay, so when x equals 0, we have the value is 0. So this is the point. When x equal to 1, we have, or when x equal to 2, we have modulus of x equal to 2. So it will be here. And when x equal to minus 2, that means when x equal to minus 2, then the value of mod x is also 2. So it will be, the graph will be like this. Okay, so this will be the graph of the modulus function. So what will be the range and domain? So domain here nothing but we can assume for any real number here. So the domain is set of all real numbers. And what about the range? Range is nothing but it will not be the value will not be negative. So range is nothing but set of all y in R such that y is greater than or equal to 0. That is the non-negative real numbers. Set of all non-negative real numbers will be the range of the modulus function. Okay. Now we also have many functions. So you just read the polynomial functions, rational functions, signum functions, greatest integer functions, trigonometric functions, inverse trigonometric functions, logarithmic function, etc. Okay, we just study about that. Okay, you just try to find the graph of that functions and the domain and range of those functions. Okay, the even and odd functions and odd functions. Okay, a function f of x is said to be even x or f of minus x equal to f of minus x equal to f of x itself for all x belongs to the domain of the function. If it is defined from R, then for all x belongs to R. Okay, that is if f of minus x equal to f of x, then we can say that the function f of x is even. Okay, and a function f of x is odd if f of minus x is equal to minus of f of x for all x. That is, if we replace in x by minus x in the function, then if we get the same function, then we can say that the function is even. And if you replace the x by minus x, and we'll get minus f of x, then the function is to be odd. Okay, for example, f of x equal to x square or any constant functions, or x power 4, x power 6, etc. These are the even powers of x. That is, this is x power 0, one is x power 0, this is x power 2, x power 4, etc. These are even functions, because if f of x equal to x square, then we have f of minus x is equal to minus x whole square, which is equal to x square itself, which is equal to f of x. So this is an example of even function. So all the even powers of x are even functions. Also, another example is sin x. Oh, sorry, cos x is an even function. Cos x is an even function. Okay. Now, the examples of odd function, we can take this as f of x equal to x, that is odd powers of x, x cube, x power 5, x power 7, etc. These are odd functions, because if you take f of x equal to x cube, then f of minus x will be minus x whole cube, that is minus x cube. Okay, so this is minus f of x. So f of x is an even odd function here. Another example of an odd function is sin x. F of x equal to sin x is an odd function, because sin minus x is equal to sin. We have this is minus sin x, but cos minus x is equal to cos x itself. So this is equal to cos x is an even function and sin x is an odd function. Okay, now property of even and odd functions are uh, if we multiply an even function with another even function, we will get an even function. And if we multiply an odd function with an even function, we will get odd function. Okay, if we multiply an odd function with the odd function, we will get an even function. Okay, you just to recall this property, you just take f of x equal to x as odd function, x square as even function. So if you are taking even function as x square and odd function as x, then we have e into e, that is even into even is x square into x square, which is equal to x power 4. We know this is even function. Okay, now odd into e, that is odd function is x and even function is x square, so we will get x cube, which is an odd function, right? Now odd function into odd function is x square, which is an even function, right? So we can just remind by using these examples x and x square. Okay, now what about the graphs of even and odd functions? So the graph of an even function is symmetric about y-axis. Here also another example of an even function is mod x. Okay, mod x is another example of even function. Okay, because modulus of minus x is nothing but modulus of x itself. Okay, so graph of an now what about the graph of an even function and odd function? So the graph of an odd function or even function is symmetric about y-axis. This is y-axis. So for example, we know the graph of y equal to x square. Y equal to x square is an even function, we know that. So graph of y equal to x square is a parabola like this. Okay. So this is, we know this parabola is symmetric about y-axis. So these lengths are equal, these lengths are equal, etc. Okay. So symmetric about y-axis. This is the graph of y equal to x square. Now what about the graph of mod x? So we know the graph of mod x is like this. So here also we can say that this lengths are equal, these lengths are equal, these lengths are equal, etc. So this is symmetric about y-axis. Okay, this is graph of mod x, etc. Now what about the graph of cos x? Graph of cos x is like this. Okay, so also we can say that this is symmetric about y-axis. So graph of even function is symmetric about y-axis. Now what about the graph of odd function? But the graph of odd function is symmetric about origin. Okay, graph of symmetric function is graph of even odd function is symmetric about origin. For example, uh, f of x equal to x is an f of x equal to x is an odd function. So the graph of the function we know this. Okay, this is y equal to x. So if you are taking any point here, the corresponding image will be here. Okay, that is this is symmetric about this origin, and we are taking the point here, so we'll have the point corresponding image will be image. It's not image, it's an uh, the symmetric about a symmetric point will be here. Okay, etc. Now what about the graph of y equal to sin x? Sin x, we know the graph of sin x is like this. So it's starting from like this. So for any point like this, we have the corresponding point here. So symmetric about the origin. For this point, we have the symmetric point will be here. And for this point, we have the symmetric point here. So symmetric about the origin. Okay. For this point, we have a corresponding point here, etc. So the graph of the odd function is symmetric about origin. Graph of the even function is symmetric about y-axis. Okay. So the graph of an even function will be a mirror image to this side and this side. Right. Okay. Now I am asking you two questions. First question is there any function which is both even and odd? Okay, you just try to find the answer of this question without looking into the textbooks or so you just try to find the answer of this question. Another question is there any function which is neither even nor odd? Can we find a function which is neither even nor odd? ഓടും ഈവനും അല്ലാത്ത ഏതെങ്കിലും ഫംഗ്ഷൻ ഉണ്ടോ? ഈ ഓടും ഒരേ സമയം ഓടും ഈവനും ആവുന്ന ഏതെങ്കിലും ഫംഗ്ഷൻ ഉണ്ടോ? Okay. Now you already know the operations of functions which are addition, multiplication of two functions, division of two functions, and also scalar multiplication a function, right? Now we have another operation, composition of functions. Okay, let x, y, and z. This is x, this is y, and this is z. Be three non-empty sets, and f is a function defined from x to y. G is a function defined from uh, y to z. Then the composition function is denoted by GOF, and it will be a function from x to z. Composition from x to z. GOF is a function from x to z and is defined by GOF of x is nothing but G of f of x. That is, first we have to perform the function f, which is from x to y, and for a function for a point x here, we have f of x will be here, and then we apply g from here. So it will be g of f of x will be uh, in z, right? So g of x g of f is a function from x to z. For example, f uh, from R to R defined by f of x equal to some x or x plus 1 whole square. Okay, and g from R to R is defined by g of x is equal to some cos x. Now what about uh, GOF? GOF of x is equal to G of f of x, which is equal to G of f of x is x plus 1 whole square. So this is equal to G of f of x plus 1 whole square is, we have G of x is equal to cos x. So G of x plus 1 whole square is cos x plus 1 whole square. Okay. So what about f for g? F for g is also from R to R. So f for g of x is equal to f of g of x, which is equal to f of g of x is cos x. So this is f of cos x. F of x equal to x plus 1 whole square. So f of cos x is cos x plus 1 whole square. So we can say that generally GOF is not equal to f for g. Okay, so you just try to find when we can say that FOG equal to GOF. Okay, also you just uh, read the portions of one function, one two function, and bijection, okay, and inverse function, etc. Okay,